Hi everyone, and thanks for joining me today as we go ahead and apply our prior knowledge of properties of exponents to questions that have rational exponents. So let's go ahead and review our properties together. Now our first property, we are multiplying like bases. So when I do that, I actually add my exponents. I don't multiply them. So in the example on the right, I notice that my bases are the same. So I'm going to keep my base the same, but then I'm also going to add those exponents. So I've got 6, and then I'm going to add the 1/2 and the 1/3. Now remember, when you add or subtract fractions, I do need to have the same denominator, so I am going to have to find a common denominator between 2 and 3, which in this case is 6. So I've got 3 6 plus 2 6 after I adjust my fractions, which is going to get me 5/6. That's going to be my new exponent. And notice that I kept the base as a 6. I didn't change it to a 12. Now in my second property, I'm going to be dividing like bases. So notice that my base is going to stay the same, and I'm actually now going to subtract my exponents. So in the example on the right-hand side, notice that the bases are the same. In my numerator, notice that I don't have an exponent, but you always know that it's a 1. Now I'm going to subtract 1 minus 3/4. I do have to find a common denominator, which is going to be 4. I've got 4/4 minus 3/4, which does get me 1/4. And notice that the base is going to stay as the 6. Now in the third property, I do have another variable. So I don't just have A, I actually have a B there. So if I have a product between multiple, let's say, variables or terms, or I have a quotient, which is a fraction, all I'm going to do is I'm going to keep my bases the same, and then I'm going to take all the inside exponents, and you're going to multiply them with the exponent that's on the outside. Now on the right-hand side, you're going to notice that you've got one variable, which is x, and it's got a power to the 1/3. And then notice that you also have the coefficient of the 16. Well, the 16 also has an exponent. It's just an imaginary 1. So I'm going to take 16, its exponent of a 1, multiply it by the 1/2. And then I'm going to take the x that has the exponent of 1/3, and I'm going to multiply it with the 1/2, which gets me 1/6. Now, anything that's raised to the 1/2 power is the same thing as saying that it's a square root. So I do have the square root of 16, which I know is 4. And then the x to the 1/6 just stays the same, with my final answer being 4x to the 1/6. Now with the division, or the quotient as you might see, notice that the exponent is actually negative. So when I have a negative exponent, I don't like to have negatives, so I'm actually going to flip my fraction. So I'm going to make it as 9/16. When I flip that fraction, or take the reciprocal, notice that the exponent now becomes a positive 3/2. Now, again, I have a 9 and I have a 16. Each of those has an exponent of a 1. So I'm going to take that 1 and multiply it by the 3/2. So I've got 9 to the 3/2 power, and then 16 to the 3/2 power. Now, to help me to evaluate this, I can go ahead and rewrite this. So now again, I've gone from rational exponent form to a radical form. So I have the square root of 9 to the 3rd power, and then I have the square root of 16 to the 3rd power. Well, I know that gets me 3 and then 4, and raising each of those numbers to the 3rd power, I get 27/64. Like I mentioned before, we don't like to have an answer that has a negative exponent, so we will have to use the reciprocal property on the base, so that way I can get that negative exponent to become positive. So same thing as flipping your fraction. So let's look at using the same properties and applying them for when we have rational exponents. So we're going to simplify this. We don't want to have negative exponents in our final answer. So again, notice that I have a -27. I have multiple variables. Those each have its own exponent, and that whole product is being raised to a power. So I'm going to take each of those exponents and multiply it with the exponent on the outside, which is 1/3. So I have -27 to the 1/3. I've got x and then 6 times 1/3. And then I have y and 3 times 1/3. And then I have z negative 9 times 1/3. So now notice here we can go ahead and simplify our answer. So I have the cube root of a negative 27 when I rewrite to evaluate that. Simplifying, I have x squared. 3 over 3 is the same thing as 1, or just y. And then I have z to the negative third. Now the cube root of negative 27 is negative 3. And then notice that the z ended up in the denominator. Now I don't like to have negative exponents in my answer, so I'm going to use the reciprocal property or flip that z into the bottom or the denominator of my fraction in order to make that 3 positive. Now in the second example, we have some more exponents that are raised to other powers. So in my numerator, what I'm going to do is I'm going to take that 1/3 and multiply it by 2, which gets me 5 to the 2/3. That kind of simplifies my answer a little bit. So now you have a question where you have the like bases and they're being divided, which means I have to go ahead and subtract those exponents. Again, please remember that you need to have the same denominator when you add or subtract those fractions. So I'm going to adjust my fraction to get them to have a denominator of 12. Now when I subtract my fractions, I'm going to get negative 1 over 12. Now again, we don't want to have negative exponents. So what we're going to do is we're going to say, all right, I need to flip or use that reciprocal property. So then I'm going to have a fraction now. That 5 and then to the 1/12 power is going to go into the denominator of my fraction. It's going to turn that exponent positive, and I'm going to have that placeholder of a 1 in the numerator. Okay, in letter C, again, we've got some powers that are raised to an exponent here, so let's go ahead and take care of that. So I'm going to take that negative 3 in the numerator, multiply it by that 1/3 that's on the outside. Also, the 8 has an exponent of a 1, so I'm going to multiply that 1 to the 1/3, which is just 1/3. I'm going to simplify my numerator. So I have x to the negative 1, and then I'm going to rewrite to help me evaluate 8 to the 1/3, which is just the cube root of 8. Now, I'm going to have to take the reciprocal property, so I'm going to have to move that x into the denominator because I have that negative exponent. And at the same time, I'm going to go ahead and evaluate that cube root of 8, which I know is 2. So notice that the x is in the numerator now. Again, yes, with the power of 1, and it's positive. I don't have to write that little exponent. And again, I have the 1 in the numerator as kind of my placeholder. And I've got 1 over 2x. Now in example 2, we're going to go ahead and take these rational expressions and we're going to have to convert them to rational exponent form in order for me to use my properties of exponents to simplify. Now in letter A, I do have a division, but you should notice that the 3 and the 6 that are on the outside, that is a coefficient. These are coefficients, and I could actually go ahead and simplify them as 1 over 2. So those kind of sit in the front. Now my 2 radicals, I'm going to go ahead and convert them into rational exponent form. So I have x, and then I have to the 4/5 power. Notice that the index is always going to be the denominator of that rational exponent. And in the bottom of my fraction here, I've got x and then to the 3/8 power. Again, the index of 8 is the denominator of that rational exponent. When I do this, I should see that now with the x's, I have the same base. So what I can do is I can take the 4/5 and I could take the 3/8 and I can go ahead and subtract those exponents. Please remember, right? We need to have the common denominators here when we're adding or subtracting fractions. So I'm going to have the common denominator of 40. And when I go ahead and subtract 32 minus 15, I get 17. And then I get over 40 as my rational exponent. You could also write this as x to the 17 over 40 all over 2. Now in letter B, we've got 2 radicals. So what I'm actually going to do is I'm going to rewrite those radicals in rational exponent form. So I've got x to the 1/3, and then I've got x to the 1/5. Now when I'm going ahead and I'm multiplying, I have got those coefficients, the 6 and the 2, and those two I can actually multiply together. when I have the like bases, so the x, those are the exponents that I'm actually going to add together. When I have the common denominator, I get 15. And when I add those together, I get 8 over 15 as my rational exponent. X stays the same, and then the 12 was already there that was multiplied. Okay, in letter C, you notice I've got roots within roots. So what I'm going to do is I'm going to start from the inside. So the very first I'm going to look at is the square root of a. So that is really a to the 1/2 power. Now notice that you still had that little 3, that index of a 3, that other root. So that is actually going to be 1/3. So that's the 1/3 power. My exponents are all 1, so the numerators of those rational exponents are all 1. So that's being multiplied by, again, look at the inside. I get the cube root of a, which is a to the 1/3. And then I have the 4th root, so I have raising again to the 1/4 power. Now, why do I convert this into rational exponent form? Is that now that the bases are the same, I can work with my exponents and I can manipulate that and use my properties to simplify. So I get a to the multiplying the power to the power is 1/6, and then a to the multiply my powers together, I get 1/12. Now when I'm multiplying like bases, I'm going to add those exponents together. So I've gone from multiplying them to now adding them together. Adjusting my fractions to get the common denominator, and then going ahead and adding my fractions together. Now you can simplify 3 over 12, which is the same thing as 1/4. Okay, so here are some things for you to remember. Any fraction that has a negative exponent, we can flip it or use the reciprocal property in order to make those exponents positive. And remember to always keep the bases the same. I'm only going to either add or subtract or multiply the exponents, but the bases are always going to stay the same, even if it's a letter or a number. Now, I hope you found this video helpful and that you can simplify expressions now that have rational exponents using our prior knowledge of our properties of exponents. Thanks for watching and have a great day.